In section 2.7, we're going to go over graphing techniques that you should have learned back in college algebra, which means we're going to look at shifting things left, right, up, down, stretching, flipping them upside down, and we're just going to streamline this a little bit more than what you saw in college algebra and just give you a quick review. And the quick review is that remembering any numbers that are inside of your function, numbers are going to shift you left or right. But it's always going to be the reverse of what you see. If you actually see a plus, you're going to shift it to the left, towards the minus numbers, if you actually see a plus. If you actually see a minus inside, you're going to do the reverse. You're actually going to shift it to the right, towards the plus numbers. That's if whatever number it is on the inside of our function. However, if you see a number that's added on the outside of your function, that is actually going to do something that's going to shift us either up or down. But what's nice about the up or down shifts, these vertical shifts, is they're exactly what you would think. If you see that there's a plus number or a positive number, positive numbers are going to shift you up. Negative numbers are going to, or minuses are going to shift you down. So the question is, what do we mean by inside and what do we mean by outside? Outside are things that are going out. You should think of Y values. That's why we move things up and down. Inside values should be things that are getting plugged into a function, which are normally X values. That's why you get shifted left or right. However, like I said, with those, you do the opposite of what you would normally think. If you see a minus, you actually move to the right towards the positive numbers. If you see a plus, you actually move towards the left towards the negative numbers. And you did this back in college algebra. And we talked about, when you did this in college algebra, a couple of key graphs that you would shift left, right, up, and down. Those key graphs are the following. You should have talked about number 1, a parabola, which is y equals x squared. The parabola has a U shape, and the 3 key points that we go through are 0, 0, 1, 1, and negative 1, 1. So we go through 0, 0, and 1, 1, as will all of our graphs, but we also go through negative 1, positive 1, so that we get that U shape. And the reason why we need these 3 points is because we're going to shift left, right, up, and down, and possibly flip things over, stretch them, that sort of thing. So we need these 3 points each and every time. The second graph that we hear a lot about, and we'll see a lot about, is the cubed graph, which is y equals x cubed. Now, the cubed graph looks very similar. It starts off by going through the 0, 0 point, and it also goes through the 1, 1 point. However, what happens when you cube a negative is it stays negative, so negative 1 cubed is negative 1. And what we get is kind of the same idea, but it's kind of flipped downwards on one side. And it kind of looks like a snake going upward. I always call this like a snake graph going upward. If you have another way of remembering it, that's fine. Our key points are that just like the other graph, it goes through 0, 0, and 1, 1. As well of our graphs, but the difference is that third point is it goes through negative 1, negative 1, and has kind of our S shape, our S snake shape going upward. Let's take a look at another graph that you should probably remember. from college algebra, which would be the square root graph. So the square root graph, which is y equals the square root of x, is going to look very similar to the parabola graph, just a slight tweak. The square root graph will look like the parabola kind of thrown on its side. It will still start out with the same original points, 0, 0, and 1, 1. So you'll start out with kind of your U shape, your parabola shape on its side. However, you can't have the full parabola, the up and the down, all thrown on its side because it wouldn't be a function, because it wouldn't pass the vertical line test. So what happens is we actually only get this part of the U shape on its side. So it's half. I always think of it as half of the parabola on its side. Half a parabola on its side. And notice the reason is because we have a square root. Remember, you can't take the square root of negative numbers. So you can't have negative numbers inside of a square root, so we won't get anything over here at all. And like I said, you won't get that other kind of matching side to the parabola at all either, because it wouldn't be a function. It wouldn't pass the vertical line test. So this is the only graph in which we only have 2 points. We just have the 0, 0 point and the 1, 1 point. Let's take a look at our fourth picture that we're going to see a lot, which is the cube root graph, which is y equals the cube root of x. Now, cube roots are different from square roots because we can put negatives in there. The reason why you couldn't put negatives under square roots is because you get imaginary numbers, you get i's, but that does not happen for cube roots because it's odd. So what happens with the cube root is actually you get the same exact points of the cubed graph, so you'll still get your 0, 0 and your 1, 1. And just like the cube graph, you'll still get negative 1, because negative 1 cubed is negative 1. And we're still going to have a snake shape. It's just going to be, instead of going upwards, it's going to be more flat and on its side. So same exact shape, just on its side. So I always think of this as like the snake laying down. So this is the snake on its side. So, but the same exact points as the cube graph, same shape, it's just kind of thrown on its side. Just like the square root graph is kind of like the parabola graph, just thrown on its side. It's just we can't include that second part to make it a full parabola because it wouldn't be a function. Last graph that we're going to use is the absolute value graph. And the absolute value graph is the y equals, and then the absolute value bars, remember, go around the x. They're like little up and down bars. Let's see what that one looks like. The absolute value graph is going to start off by going off through the same points, the 0, 0, the 1, 1, and just like the parabola, the negative 1, positive 1. The only difference between the absolute value graph and the parabola graph, the x squared, is that instead of a U shape, it's going to be a V shape. So, the idea is it's still going to go through the 0, 0, and it's still going to go through the 1, 1, like the parabola, and it's going to go through negative 1, positive 1. It's just the actual shape is a little bit different. It's a V shape. And the reason being is it should remind you a lot, if you were just kind of focusing on this, the line y equals x. Well, the line y equals x would look like this. It's just, what does the absolute value part do to it? Well, remember what an absolute value does is an absolute value makes any parts that are negative turn positive. So this negative part of the graph because we're taking the absolute value, just becomes positive and flips up. That's why the absolute value graph looks the way it does, the V shape. And so that's going to be part of something you have to have memorized, is all these shapes. Which one's the square root graph? Which one's the cube root graph? Which one's the cube graph? Which one's the x squared, the parabola? Which one's the absolute value graph? You need to be very comfortable with these. And how to shift them left, right, up, and down, and whether or not something's on the inside or the outside. Because when we're all said and done with this, what we're also going to do is start shifting other functions. So before we get started, a quick summary again is if something is on the inside of our function, it's going to move us either left or right. But it's going to be the opposite of what you would think. If you actually have a positive number, you're going to move left. If you have a negative number, you're actually going to move right. However, we're also going to have another part to this on the outside of our function, possibly. Anything on the outside of our function is going to move us up or down. But that one will be exactly what you would think. So positives will move you up and negatives will move you down. It's exactly what you would think. And again, the reason why it's moving you up or down on the y-axis is because it's talking about things are coming out. Things that are on the inside always affect your x values. That's why you move left or right along the x-axis. So, continuing along, what you would need to make sure that you are comfortable with all 5 graphs, because this is what we're going to do. We're going to move them left, right, up, down, flip them upside down, and stretch them. Now let's take a look at graphing some functions. The first thing that we'll look at is A on our next page, which is y equals the absolute value